This lesson is going to cover the cosine rule. So the cosine rule is trigonometry that we apply to a non-right angle triangle. The lengths are usually represented by lowercase letters and the angles are represented by capital letters. When we're looking for the cosine rule, we look for a non-right angled triangle. We need to know either two sides and the angle that's in the middle of it. So for example, we could know this length and the angle in the middle. So it's always has to be the angle between the two lengths, and that would enable us to find another length. Or we can also use the cosine rule. If we know all three lengths, then we can work out an angle. Okay, so watch out for two lengths and an angle in the middle, or all three lengths. They're your information to tell you that you need to apply the cosine rule. There are three ways of writing the cosine rule for finding the length. However, you only need to know one of them. When I'm using this rule, I always stick with the top one, and I always just use that whatever length I'm trying to work out, I call that length A, and the angle that's opposite is the angle A. So if I wanted to work out this one, the angle opposite becomes the angle A. So all the way through this PowerPoint, I'm going to apply this top one here. That saves you memorising all three. So this would help us to work out a length. Later on, we'll look at how we work out an angle. On the next slide, I'm going to ask you to have a look at these triangles, decide which ones we could apply the cosine rule for. So remember, cosine rule is where we know two lengths and the angle in the middle, or we know all three lengths and we're asked to work out a missing angle. If you could pause it now, have a look at these triangles and determine whether we could apply the cosine rule or whether we need to use something else. Okay, pause it. And when you're ready, these are the answers. So this one, length, length, angle in the middle, length, length, angle in the middle, and this one, all three lengths, we're asked to work out an angle. Just as a bit of a recap, right angle triangle here, SOHCAHTOA should pop into your head. This one, you can see we've got two pairs, sine rule should pop into your head. This one, two pairs, sine rule. This one, two pairs, sine rule. So let's have an example how we apply the cosine rule. We're going to first of all look for a missing length. Missing length means we use this formula that, again, you're not given, that you've had to memorise as you go into your exam. I'm trying to work out length A, the angle opposite therefore is angle A, which is actually how this triangle is set up anyway. The first step is basic substitution. Replace the letters B and C with the lengths that you know. It doesn't actually matter which way around you use them because you're going to square them and add them. So 3.7 squared add 4.9 squared is exactly the same as doing 4.9 squared add 3.7 squared. So basic substitution, all I've done is replace the A and the B and the cos A with the appropriate numbers. Now I'd like you to use your calculator and pause the video here to type that in, please, because if this is going to go wrong, it's how you type it in your calculator. So if you could type this in your calculator and when you're ready, press play to make sure you get the same as comes up. Okay, if you could pause it. Let's see if you got that right. So that makes A squared here. If you didn't get that right, just check that you're putting a time sign in all the appropriate places and that you haven't put any unnecessary brackets in. So that gives us A squared. Now, a common mistake is that sometimes people forget to square root this and just write that down as their answer. Look at your triangle. 22 is way out compared to the other two lengths. So always check in an exam that your answer seems realistic. So this one needs square root in to get the actual length A, and then we can round that to a more sensible answer. So length A would be 4.73 to three significant figures. No units on this one because we don't know what these units were. I'd like you to have a go at working out the missing lengths on these four triangles. Press pause to have a go and then press play to check your answers are correct. Let's see how we get on. Right, so here are your four answers. I'm just going to go over the first one to make sure that if you didn't get this right, that you know where you've gone wrong. Well done if you did get all of those right. So we've used our basic rule for finding the length. I've replaced B and C with 7 and 11. This is my A that I'm trying to find out, which means my cos A gets replaced with cos 62. Typed all of this into the calculator to get me A squared, and I had to remember to square root it. I've just rounded there at the end and I've put my units on. Okay, same process for all 4 of those. If you did make any mistakes, just check your calculator that you typed in all of the time signs and all of the signs correctly. Moving on, we've now got to work out a missing angle. Notice we've got all 3 lengths and no angles, so it's a huge clue in an exam that you use in the cosine rule. The problem we have is that we need to rearrange our formula. You have 2 choices in an exam. You either memorise both formulas separately, which is what I would recommend, or you get really good at rearranging equations, which I also recommend, and that way you can always do it in an exam anyway. Maybe make some flashcards. These are really important formulas to get down. So notice we now have our formula that gives us cos A, so we're working out an angle. If this is cos A, then it's really important because it's the only positive that A squared is the one that's across from it. So the 12 has to be A in this case. B and C can be either way because we're subtracting them anyway. So substitution, replace all of the A, B and C with the 3 lengths. Make sure the A is the one that's across from the angle you're trying to work out. So basic substitution. Again, just like before, I'd like you to use your scientific calculator. Please use the fraction function. It will make your whole formula much more accurate and easier to type in. So if you press the fraction button to start with, you can type this in and it should look exactly the same on your scientific calculator as it does on my screen now. Press play after you've had a go at that and see if you get the same answer as me for cos A. Cos A ends up being this. You might need to press S to D, or you're fine to leave it as a fraction, but this is the decimal if you change it from a fraction to a decimal. Just like whenever we do SOHCAHTOA or when we did the sine rule, whenever we need to find an angle, we've got to use the inverse of the function cos, sine or tan. In this case it's cos, to get rid of that cos. So we've got to do the inverse. So the inverse of cos is the cos minus 1. So you have to press shift and cos to get cos minus 1. You can press shift cos to get cos minus 1 and then type in ants, which is ANS, on your scientific calculator. Gives you angle A as 52.6 to 1 decimal place. And that's the end for that one. So little extra step at the end whenever you're working out an angle, you've got to do that inverse function. I'd like you to have a go at these 4 questions. Can you pause it and then press play when you're ready to check your answers? Let's see how you got on then. So these are the answers for these 4 questions. I'm going to go again through one of the questions. I'm going to pick this one just to mix it up a bit. This time I'm trying to work out the angle here, which means it's really important that I use this one as my positive in the formula. I've stuck with the same formula all the way along, even though this is question B, because this is question D and there's no D, so it makes sense. So we've got 13 squared minus 9.1 squared minus 10.5 squared, because it doesn't matter which way around the B and C go, all divided by minus 2 times 9.1 times 10.5. Type that in, get cos A is this. If you change it to a decimal, that's also perfectly fine. You can just leave it in your calculator and then do cos minus 1 ants, and you get 82.8 degrees to the nearest 1 decimal place. Well done if you was getting those right. If you didn't, just check where you might have put that in wrong. Last thing, so in an exam, they like to interleave with some other subjects. So if you read through this one, it interleaves with bearings. Very common when they're using sine, cosine, to use a bearings question as well. So Nottingham is 40 kilometres due north of Leicester, which means that this is north, which is also important when it comes to bearings, and there's 40 kilometres between them. And Swadlincote is 32 kilometres from Leicester and 35 kilometres from Nottingham, so that's just shown here. Calculate the bearing of Swadlincote from Leicester. So bearings are always measured from north, and we're going from Leicester, so that means the answer needs to be this angle here. You can see the problem there, that's outside of our triangle. What we can calculate is this angle here. It's an angle, we know all three lengths, which means we need to use our angle formula for cosine rule. Substitution into that, replacing A, the B and the C with what we know, making sure if we're working out this angle, A is 35. Type that in your calculator to work out what cos A is. Whether you leave it as a fraction or change it to a decimal, that's perfectly fine, but finish off your calculation by doing cos minus 1 of the answer. I've rounded this one to the nearest degree, so that makes this angle on the inside of our triangle 57 degrees. But we haven't answered the question. We've got to find the bearing here. So bearings, full circle, add up to 360. So we do 360 take away our 57 degrees, means the answer to this question would be a bearing of 303. Okay, I'd like you to head over to Teams to have a go at the worksheet to go with cosine rule. Good luck. Remember, you can refer back to this video at any point.